As you lead your organization into cloud-native development, you will find that containers are now the standard for building, shipping, and running applications. Containers offer speed, scalability, and consistency, but they also create new security challenges that you must proactively address. In this lecture, you will learn what makes containers unique, where security risks emerge, and how you can lead the design of secure containerized environments across the full application lifecycle. Containers are lightweight, portable units that bundle application code with all its dependencies, libraries, and configurations. Unlike virtual machines, containers share the host operating system kernel, making them faster to start, smaller to run, and easier to scale. However, this architecture also introduces unique security concerns. A vulnerability inside one container can potentially affect the host or neighboring containers. Misconfigured container images, exposed APIs, and insecure orchestration platforms can quickly become attack paths. As a security leader, your job is to understand these risks and ensure that your teams treat container security as an integrated part of their build, deployment, and runtime processes, not as an afterthought. When working with containers, you face several key risks that can threaten the security of your environments. First, vulnerable container images are a major concern. Many development teams pull base images from public registries without verifying their integrity or security. These images often contain outdated libraries, misconfigurations, or embedded secrets. Second, you must watch for runtime risks such as container escapes, where an attacker breaks out of a container to access the host or other containers. Poorly isolated networks and excessive container privileges can make these attacks easier. Third, misconfigured orchestration platforms like Kubernetes can become a serious risk if role-based access controls, RBAC, network segmentation, or audit logging are not properly enforced. Your responsibility is to build a security model that addresses all these risks across build, ship, and run phases. Securing containers requires a layered approach that begins before the first image is ever deployed and continues through the entire application lifecycle. You must start by enforcing the use of trusted base images from verified sources. All images should be scanned for vulnerabilities continuously, both at build time and regularly after deployment. Tools like Microsoft Defender for Containers, Aqua Security, or Anchor can help automate this scanning. Next, you must implement runtime security policies. Containers should run with the minimum required privileges. You should avoid running containers as root, enforce read-only file systems where possible, and tightly restrict inter-container network communication. For orchestration platforms like Kubernetes, you must lead the enforcement of strong RBAC policies, ensure namespace segmentation, and require audit logging to detect unauthorized activities early. Regular security posture assessments of clusters using tools like Azure Kubernetes Service, AKS, Defender, or KubeBench will help maintain compliance and visibility. You should also ensure that secrets management is handled correctly. No sensitive data should ever be embedded inside container images or passed as plain environment variables. Instead, you must integrate secure secret injection methods using services like Azure Key Vault or Kubernetes Secrets Encryption. Finally, you need to build automated continuous monitoring and threat detection across your container fleet, watching for behavioral anomalies, privilege escalation attempts, and network policy violations. When you implement these practices, container security becomes a natural extension of your DevSecOps model, built in, not bolted on. Containers may be lightweight and short-lived, but the risks they introduce can have long-lasting consequences. As a security leader, you must ensure that speed does not come at the cost of visibility or control. Securing containers is not just a technical effort. It is a leadership-driven initiative to build a culture where fast also means secure. So, what's your leadership takeaway? Containers offer unprecedented agility for your teams, but only if you build security into every layer, from the image to the runtime to the orchestration platform. Your role is to lead the shift towards secure container adoption by driving best practices, enforcing policies, and ensuring continuous visibility. When you lead with security in mind, containers will become not just an enabler of innovation, but a foundation for resilient, trustworthy cloud-native applications.